Hi everybody, welcome back to another My Tutor online school tutorial. Today GCSE Maths, and we're looking at two different topics, vectors and 3D trigonometry. So this lesson is 1 hour long, so it will finish at 3 p.m. This is me, Molly. I'll be running the session today. Most of you probably know me by now. It's the same people coming most of the time, but I'm just finishing my second year studying computer science and maths at the Uni of Bath. And I've done over 200 lessons with my tutor. So hopefully I know what I'm doing and this lesson will run smoothly. So a few more people just arriving. I think most people are here now. Okay, cool. So let me just get rid of this. Cool. Don't know why this is, that's annoying. We'll just deal with that bar at the bottom. Okay, so today how this is going to work is people have asked for a quiz at the beginning. So what I'm going to trial is doing a quiz at the beginning and then the same quiz at the end. And we'll see like the improvement that hopefully happens to see, yeah, how much you've like picked up from the lesson. So that's what we're going to give a go today. Someone said, are we learning proof today? It's like vectors and vector proofs. So kind of prove that these two lines are parallel and so on. Algebraic proofs and stuff we can definitely cover in another week, I'm sure. We can get that added to the schedule. Yeah, cool. So like I said, there's two distinct topics today. It's vectors and vector proof, and then there's 3D trigonometry. So that's the two kind of things that we'll be doing. So, okay. Let's get up Kahoot and we'll jump straight in with the quiz at the beginning. Like I said, don't worry if you don't know it. I'd prefer it if you leave it blank, like don't answer it rather than guess, so that we can get like an accurate representation of who actually knows what. Do you know like how much people know? So hopefully that makes sense. Gosh, Kahoot really doesn't want me to just do it easily today, does it? Here we go, vectors and 3D trig. So don't worry if you don't know any. Hopefully by the end you'll be able to answer most, if not all of them. So there aren't loads of questions on here, but just enough that it kind of covers most of the topics. So there you go. Go to kahoot.it or the Kahoot app and enter this game pin 5441777. And there are currently 22 of you, so I'll wait until there are 22 or almost that and then assume that people aren't coming. Okay, half of you are in. Thanks, whoever's nickname that is. Okay, is anybody still waiting to join? Just let me know on the chat or Q&A. Oh, I didn't say that at the beginning. If you are new, make sure to make use of the chat and Q&A. Let me know if you want me to go over something else or what's your Snapchat? Okay, someone's asked me to wait, so I'm just waiting for them. Okay, anybody else still waiting? Okay, still coming in. Lucky dog 32, that definitely means that someone just tried to swear on it. I know how Kahoot works. Okay, we ready to go? Okay, I'm gonna get started. Don't worry if you haven't managed to get in, just like kind of play along and see. It doesn't matter if you can't submit. So we'll get started. Okie dokie. For this first one, I'm not going to explain why each one is the right answer because it's the same quiz as at the end. And obviously the whole lesson is going to be explaining the answers. That's quite small. That says A is 3, 8 and B is minus 7, 2. And we want to write 2A plus B as a column vector. Okay, brilliant. Lots of people got that, so well done. We'll learn how to do that throughout the lesson. So in this question, we'll see a diagram and we want to know how to express the vector from B to C. If you have no idea what I'm on about, that's totally fine. That's the point of this lesson. So don't worry at all. These times go really, really quick as well, because it's just a quick little, if you know it, you'll know it kind of thing. Yeah, so don't worry if you don't know what a vector is, don't understand. Okay, cool. A lot of people got that, which is really, really good. And we'll look, I can see totally where these 9 people went wrong. So we'll learn about that today. Here we want to know what the vector is from X to Y. So it's kind of similar to the previous one. Yeah, like I said, don't worry if you don't know them. They're not the kind of things that you can work out unless you know. Perfect, well done. A lot of people got that. That's really, really good. Okay, so this is more of like a proof kind of one. So which of these vectors is parallel to A plus 2B? So you might not know how to spot parallel vectors. That's totally fine. You will do by the end of this lesson. Okay, a lot of confusion with that one, but well done to the 4 people who did get it. Might have been a lucky guess, but well done anyway. We'll learn why that is the answer at the end of the lesson. Well, by the end of the lesson. Okay, now we're switching for the last 2 to some 3D trig questions. And we want to know what the length of EG is. So you've got a minute for this because it'll take a bit longer. In fact, maybe a minute isn't long enough, but give it a go. Okay, I think almost everybody has got that in. I've just realized something. I'm not, yeah, okay. 12.21. Yeah, a lot of people got that one. So well done. Again, we'll see at the end why that is. I mean, I was just having a look and I didn't get the right answer for that one. So maybe I need to double check my question there, but a lot of people seem to get it. And now we want to find the length of GC. So GC is the one down the side on the right. So see if you can find what that one is. See how many answers we have. 20. I think that's everybody. Oh, there we go. Oh, brilliant. Loads of people got that one. That's fantastic. So let's have a look at the podium for who knows their stuff beforehand. Friendly Hamster 11. Bob, a classic return. And Louise came in first. So well done. We're going to be looking at some questions. Obviously, it's difficult to put really hard questions in the Kahoots because they'll take a long time. That's a bit boring for in a quiz. So even if you've got loads of those, definitely stay tuned because we'll be looking at some much harder ones as well. So let's have a look at the report and we'll see what percentage in total was got. So 36%. And what we're going to see is if that goes up at the end. And if it doesn't, maybe I should quit. So let me know, did people like that method of doing things? Is this something that people want again, to do a quiz at the beginning and the same quiz at the end? Let me know, or you can let me know afterwards once we've done it. Yeah, cool, just so that I know what to keep. Let me see what people have said. Oh, cool. Yeah, everyone's saying yes, definitely. Very effective. Awesome. Cool. Thank you, guys. I've planned doing that into my times for the rest of the week. So I'll definitely keep that up. Awesome. Cool. So let's jump straight into the content for today and we will start with vectors. So what on earth is a vector? All it is it's kind of a distance and it tells you what direction it's going in as well. So the best way to think about this initially is think about it on a graph. So if we have a vector that looks like this, and this is called a column vector for, you know, the obvious reason that it's in a column, then what this means is that if we move this little point here, if we move this by the vector 2, 3, it means we move 2 units this way and 3 units this way. So this vector here, this, let me do that in a different color. This vector is the vector 2, 3, because it's gone 2 across and 3 up. Similarly, a -2 means that it goes left and a -3 means down. So you can read it like a coordinate where the original point is the origin, and then it goes to the point 2, 3. The reason that it's useful to write it like this is because we can't always talk about things in terms of coordinates and in terms of graphs. For example, we might not start at the origin and say, well, I want to move by the vector 2, 3 again. And then you'd go up to the point 4, 6, but it's still by the same vector. The other reason is because some things just aren't graphical. We can use vectors to describe movement of anything, of a car, an ant moving, anything like that really. And you're not always talking about that in terms of a graph, not in terms of exact points. So yeah, this is, I suppose, split into 2 sections, talking about column vectors and talking about combining vectors together. So hopefully this all makes sense with this. Now, adding, subtracting, multiplying vectors is super, super easy. So for example, if we have the vector, let's stick with 2, 3, and we want to add the vector -1, 7, all you do is you add these two and you add these two. You literally just add across. So this becomes 1, 10, because 1 is 2 and -1, and 10 is 3 and 7. And we can see this visually. If we start a point here, and we first of all move 2 right and 3 up and end up here, and then move 1 back this way and 7 more up, it's exactly the same as if we'd move, let's do it in orange, 1 this way and 10 all the way up. And I'll draw it in green what these vectors actually are. It's saying that this vector plus this vector is equivalent to this vector. We always draw vectors as arrows because it's like you can draw anything, any movement as a some diagonal arrow. And then the way that we split it up is kind of in a triangle. So this we can see they've moved right and up. So that's just how we talk about vectors and kind of putting it into a shape. Somebody said, can vectors be with any polygon? How do you mean? Do you mean like, as in, because here they form a triangle, could they go in different directions? Because they could certainly, we could have ones like going this, like going around, say, a hexagon or something. Vectors are basically just straight lines. Ooh, okay, cool. So someone said, Okay. Cool. So people have asked about subtraction, multiplication, division. So we can't multiply vectors together. And the reason is because it doesn't really make much sense to do something like when you multiply, you're doing it. So if you multiply something by 2, you're doing that thing 2 times. If you multiply something by a vector, how many times are you doing it? You don't know. It's very unclear. So we're only ever going to get being multiplied or divided by a scalar multiple, and that just means a straight number. So I'll go over that first, and then we'll cover subtraction. So for example, we could have 2 lots of the vector 2, 3. And all that means is that you multiply both bits by 2. Super simple. So this is just 4, 6. And we can see why. Because if we travel from here to 3, and then do it again, see, that's exactly the same as if we'd gone 4 across and 6 up. So that's all it means. It means that we're doing this movement that we've defined by this vector. We're just doing that movement twice. So we can then get questions such as, I'll explain subtraction first, exactly the same as addition. If we have 5, 6 minus 1, 3, this is 4, 3. We literally just subtract across. And that's because a negative vector is a vector in the other direction. So if this vector is represented, oops, didn't mean to do that. If this vector is represented by A, then this vector, the one that's parallel, imagine it's overlapping it, this is minus A. So when we say minus 1, 3, what that means is we actually go backwards 1 and 3 steps. Now if you've gone forward 5 and back 1, that's equivalent to having gone forward 4 overall. Someone said, can it be in square form, in a square? So do you mean like vectors going like this? I assume so. That's allowed, yeah. But we always talk about, if we're combining 2 vectors, it's always going to form a triangle. Because if we talk about going from here to here, it's the same as going here and then here. So hopefully that makes a bit of sense, and it will do the more questions that we do and the more practice that we do. Okay, so that's how we kind of write it in this column notation. But sometimes we don't always want to know what the actual vectors are. We just want to know vectors in terms of other vectors. Bit of a weird concept, but we'll get used to it. So we represent them as lowercase letters, so A, B, C. And if they're typed in a question, you'll see them bold. So for example, here, we say this vector A minus B, and you see that they're bold here. Or in a question, they'll be bolded. However, it's pretty hard to write bold. So when we write them down, we write it with a line over the top. So if I'm going from here to here, I would call this vector A. And that means the same thing as a bold A. The reason that we write it in bold is so that we don't get confused if there's a scalar A. Because we know that this A, when we represent it with a line over the top of bold, means a 2-dimensional thing, so a vector 2, 3 or something, whereas just an A just means a number, so 3.5 or something. So we just have to distinguish that and be careful when you're working with them. Somebody's just asked, can you divide vectors? A couple of people have actually. No, it's the same as multiplication. You could only divide by a scalar factor. So if we had 10, 5 divided by 2, what does everybody think that will be? Yeah, perfect. A lot of people said it. It's 5, 2.5. And how we've done that is we've done the 10 divided by 2 and the 5 divided by 2. The other way that you can think about it is that when you're dividing by 2, it's like multiplying by a half. So what this means is that instead of going all the way 10 and 5, we just do half of that. We just go 5 across and 2.5 up. So it's just half of the original thing that we were trying to do. So yeah, multiplication and division you can only do by scalars, not by other vectors. Okay, so back to this notation. This is kind of the core for all vector questions. If we have this here, and normally we label kind of points with capitals. So from A to B is vector A, from B to C, in fact, let me do different letters so that it's not as confusing. Let's call them X, Y, and Z so they're completely unlinked. So to get from X to Y, it's vector A, and to get from Y to Z, it's vector B. Now remember, vector A, this could be 4, 1, or it could be 3, 2. We don't know, and we don't really care, because we're just going to call it vector A for now. And similarly, vector B could be anything. We really don't know, and like I said, we don't care, because that's not what we're looking at. We're going to look at what X to Z is. I'll put this one in blue, in terms of A and B. And the way that we do this is we think, okay, well, currently we're getting from X to Z like this. We could also get from X to Z like this, here and then here. And what's that? That's vector A and vector B. So what's the solution? X to Z is A plus B. And it's as simple as that. If you want to work out a way to get from one vector to another, you simply find a different way of going from that one vector to another. And write down that that's what it is. So we can now get rid of this question mark. And the way that we write this out is we say that X to Z equals that. So you put a little arrow on top. So for example, to describe this one, you'd say X to Y is vector A, and Y to Z is vector B. Now, the reason that this is important is because you need to know which way you're going. Because for example, X to Y is vector A. Y to X, however, that's going to be vector minus A. I can write this on here as well. Y to X is minus A. So it's really important that you know which direction you're going in, because vectors are directional. As I said at the beginning, they represent a distance, some sort of movement and traveling, but in a specific direction. So that's why whether you're going from X to Y or Y to X, that's really important. It really matters which way it is that you're going. Someone said, what's the line on the top? So when we see vectors printed like this, so in an exam paper or a textbook or a question, they're printed bold. When we write them, it's pretty difficult to write bold, so we just put a line on top. And the reason that we do that is to distinguish between a vector and any other variable. Because if we just wrote something like A, that's a very bad A. In maths, that implies that it's a number, or like representing some sort of just scalar singular number. Whereas this, we know represents a vector, so two numbers in two different directions. So that's why we put the line on top. And it is important. You might get marks deducted if you forget it, because A bar, as I'll call it, is different to A. Somebody said, what's a scalar? That's a good question. I feel like I've thrown that word around a lot and not properly explained it. So a scalar is just kind of a single number. So a scalar is a one-dimensional number. So you see how we're thinking about vectors in 2 dimensions, moving 3 across and 4 up or something. A scalar is one direction. So 1, 2, 27, pi, -5, just a single number, just a one-directional number. Whereas vectors are in 2 dimensions. Hopefully that makes sense. I guess it's a word that you use more kind of in higher education, but it's not really introduced to you earlier, but you all know what a scalar is. You just kind of haven't learned the word. Somebody said, can we divide vectors by 0? No, you can never divide anything by 0. Scary. No, you can't. You could multiply them by 0, and then it would just be 0. You know, if you do something 0 times, you just stay where you are, but you can't divide by 0, because then you'd be trying to divide each element by 0, and we know that that's illegal. So, yeah. Okie doke. So hopefully this makes sense. And this is going to be kind of the bulk of what we're looking at, is trying to get from one place to another and seeing how we can represent that in terms of vectors. So let's grab an example. For example, this one. Okay, oh, is this one too hard to start with? Maybe. I'll start with a slightly simpler one to begin with, and then we'll come to that because that's a good challenge one. Let's do this because it's a good kind of summary for everything. Someone said, what's 0 to the power 1? 0. Because anything to the power 1 is just itself. So if you do 0 one time, it's just itself. 0 to the power 0, now that's interesting, and mathematicians can't agree on that. But I'll digress. Someone said 0 to the power 0 is 1. Some people think that. Some people think it's 0. Some people think it's undefined. Interesting. If you're curious, go and read. There are some great articles on it. Back to the actual topic, somebody's asked what grade is vectors. That's a good question. So I think questions like these, so kind of adding vectors and stuff like that, that is grade 5-ish, I would say. So if you have something like this, let's give it a go as a question. So this is a grade 5-ish question. So let's say A is 1, 3 and B is -2, 4. What is 3A plus B? So give that a go. I'll give you 30 seconds or so to have a go at that, and then I'll show you why. Okay, a couple of people have given me answers. I'll reply to you if you're correct. Okay, right, okay, there are a lot now, so I'll stop replying to them. Perfect. Everybody who sent one in has got it right now, and loads of people have it, so that's perfect. You have to do this in 2 stages. So first of all, we think about what 3A is. So we just times both bits of this by 3. So we get 3, 9. And then we're going to add B. So we subtract. So basically, this is just adding B here. So then we work this out, and we say, what's 3 minus 2? Well, it's 1. And what's 9 plus 4? It's 13. So it's 113, which loads of you got, which is really, really awesome. Cool. Okay. So let's hop back over to this stuff and have a go at that question that I just grabbed from the worksheet. So today, some of what I'm using is from Maths Made Easy, and in a shock plot twist, some of it's from different websites. Oh my gosh. So these Word documents here, like where I got the first one from, these are from Mr. Barton Maths, which I'd really recommend. Got some great resources on there. And this that I'm going to be using is from TES, the teaching website, which are for free download. So have a look there. I know someone said, how could you? I know, never going to get sponsored by them now, am I? Okay, so let's go ahead and have a look at this question. So we've got a triangle here, and so here you can see this is what I'm talking about. So you put an arrow over the top to say P to Q, and that's B, and they've bolded it here because they can, because they're on a computer. So this is the vector B, and this is the vector A. So let's express the following ones in terms of B and A. So the first one is P to Q. So this is a nice easy one. What's the vector P to Q? Yeah, perfect. Everybody's getting that one. It's just B. That's just reading off the diagram and seeing that it's here. It even says it up here. So that's perfect. Okay, let's have a look at part B. What is the vector R to P? Yeah, oh my gosh, flooded in. Brilliant. This one is minus A, because P to R is A, so if we go backwards, it's just minus A. So brilliant. So many people got that. That's really, really good. Okay, what about part C? And now we want to go from Q to R. So a bit trickier. Look, gosh, so many coming in quickly. Brilliant, loads of people getting that. Awesome stuff. So yeah, it will be, I would write it as A minus B, or you can write it as minus B plus A. But yeah, we have a look at where we're going. So we travel along here. So we see that we do a minus B and then an A. I just write it this way round because I think it looks neater than minus B plus A, but either is totally correct. And then finally, what about D? What about R to Q? Brilliant. Perfect. This one is B minus A, or minus A plus B. And we can do that in a couple of ways. We can either look on this diagram and see that it's going to be minus A from here and B from here, or we can see that this is the opposite of this one. So we just make everything here negative. So minus A, so A becomes minus A, minus B becomes plus B. Yeah, either method is equal. But brilliant, nobody got those wrong who messaged. So perfect. And this is kind of your most standard kind of question, like express these vectors, but we can definitely get ones that go a lot harder. So we'll have a look at some of them. So for example, let's have a look at this. We might not do all of them. I'll have a look at what we want to do. So yeah, okay, I guess let's just jump straight in to OB. So part C here. What do you think OB is going to be? Brilliant. Somebody's already got it. Brilliant. Okay, I'll go through it now. A lot of people got it. The key thing here is that if vectors are parallel and exactly the same length, then they're the same vector. It doesn't actually matter where you draw them. For example, this could be like 3 across and 2 up. So is this. That's 3 across and 2 up. So they're exactly the same vector. And because this is a parallelogram, so AB is parallel to OC and exactly the same length. That means that this vector is X and this vector is P. So we can actually work it all out. So OB is going to be P plus X, which a load of you got, which is really, really good. But it's this key idea of if they're parallel and in the same place, then it's the same. Okay, let's have a look. I'll tell you what, let's jump straight in actually. Oh no, I'll explain one thing first about parallel vectors. So this was one of the questions on the quiz that wasn't as well answered, which is fair enough because I hadn't taught it to you yet. So parallel vectors, super simple. It means that one of the vectors is a multiple of the other. For example, A plus B is parallel to 2A plus 2B. And that's because this can be written as 2 lots of A plus B. So that's where the kind of vector proofs part comes in, because we've written this in terms of this one. We've written it as a multiple. And the reason for that is because if we think about it, let's just call this vector a plus b. Well, 2a plus b just means doing that twice. So wherever we put it, we're going to put an a plus b and then another a plus b. And of course, that's parallel. Extending it doesn't make it not parallel. So that's the key thing. You want to work out if it's a multiple of the other one. And this is quite easy to spot usually. So I want to get moved on to 3D trig. So we're just going to have a go at this as a final one. Now, this is a difficult question. So I don't think I'm going to ask you guys to go through it. I think I'll just go straight into it. Or let me have a look. So we've got a bit of waffle that tells us what's going on here. So vectors, so AE is 3a minus 2b, and DC is 2a plus 4b. E and B are the midpoints. So E is exactly halfway between A and D, and B is exactly halfway between A and C. So we want to find an expression for EB and say whether it's parallel to DC. So does anybody have any ideas for how we could do this? Someone said when maths teacher says this will be easy. Yeah, this is not easy. I'm not going to pretend that this is easy. However, it's very, very doable. I think the hardest thing here is understanding what to do. Doing the maths, you've all just done all of the maths that you need for this, I promise. Yeah, someone's got a really, really good idea, which is fab. Perfect. Okay. So a couple of people said something really, really fab, which is that AE is equal to ED. Because E is the midpoint, if A all the way to D, oh, sorry, it says AE, my apologies. AE is 3a minus 2b. This means that AD is also 3a minus 2d. Because it's the midpoint, to get from A to D, we've got to go again. So we know, and we can write this down. With questions like this, you've got to kind of explain your working. So we just say ED equals 3a minus 2b, because it's the midpoint there. Anyone got any ideas for what we could do next? Okay, so what we want to do is, because to get from E to B, right, it's here. So we either need to go up here and down, or ED, DC, CB, which is what someone said, which is spot on. Now, because B is the midpoint here, if we knew what AC was, we could half it to find AB or BC. So what's AC? Remember what we've done before? We want to go via D. So what do you think AC is? I'm just working it out myself as well. Cool, a couple of people have got that, which is fantastic. So we see that we have to go from A to D to C to get AC. And so we do 2 lots of 3a minus 2b, and we add our 2a plus 4b. And that gives us AC. Sorry, this is AC. And that gives us 8a. So now that we've got that, we can know what A. Let's go down here and then up to B. To find EB, we'll do this. We'll do ED plus DC plus CB. So CB, if A, actually let's do this one, because it's, to go to E to B, it's fewer to do. And we know that if A to C is 8A, A to B is 4A, because it's just half of that, because B is the midpoint. So that means, what will E to B? What will that be? Perfect. It will be A plus 2B, because we do minus this. So minus A minus 2B plus 4A. So EB, let's do this in a different color. EB equals A plus 2B. Now, is that parallel to DC? And if it is or isn't, why? Perfect, yeah. And someone's given, yeah, a couple of people actually have said it in exactly the right way. So they are parallel. And the reason that you'll need to give to make it be kind of properly mathematical, we want to say yes, because DC, so 2A plus 4B, that's equal to 2 lots of A plus 2B. So you see how we've represented it as a multiple of this. You have to write out what the multiple is. But loads of you had exactly the right idea and were saying that it was a multiple. Perfect. You could also say that this is half of this. Doesn't matter which way around you say the multiple. So fantastic. So I'm going to quickly move on to 3D Pythagoras and trig. This won't take as long at all because we've already been over trig. So the main thing for today was vectors, but we'll go over this as well. If you've got any questions, pop them on the Q&A, and hopefully, hopefully we'll be able to come back to them at the end. But I want to make sure that I have time for the quiz. So, 3D trigonometry. Hopefully we remember our trig rules. I'm not really going to have enough time to go over them again today, but I have done lessons on them before. So the first one is Pythagoras Theorem, where a squared and b squared is c squared. So we square these two lengths here, and it's equal to the square of this length. And then we have this, if you remember, SOHCAHTOA. So working out a length of the triangle. You label the sides, work out which two you have, work out which trig function you should use, and then always put it in as trig function of the angle equals first one over the second one, whichever it is. So let's have a look at one such as this. Okay, so here, I'll walk you through this one. So I think 3D trig questions always look really, really overwhelming to start with, but they're actually totally fine, and they're just things that we're really used to doing. So here's one that uses Pythagoras. Ooh, where have I gone? Can you guys still see me? I can't see myself on there, so. Yeah, you can still, okay, cool. Okay, I don't really know what happened there on mine, but that's fine. Okay, so as I said, it's all stuff that we've seen before. So this is going to take us 2 steps. So what we see, this just tells us what we know here, that we've got 5, 3, and 7, and that we want this length A to G here. So what we're going to have to do is somehow make this into a triangle. So what we do is we draw a line from A to C across the bottom, like imagine this kind of over on the base of the triangle. And then can you see, and I'll draw it out here for you, if we just lift this triangle off, A, G, C, we've got a triangle now like this, with this one being a right angle. So we know that this is 3, and this is what we're trying to work out. So we want to know what this across the bottom is. Well, we can do that because we've got another triangle. Look at this, we've got this triangle here. And we can lift that triangle out and have a look at it. 5 and 7, and now we want to know this. So hopefully that makes sense. Someone said press Alt F4. I study computer science. Okay. So to find y here, this one AC across the bottom, we're going to use this green triangle here. So we say that y squared equals 5 squared, oh, not 5 to the 7, plus 7 squared, which is, oh my gosh, 49, 62? 72. Geez, I really need to improve my mental math skills, don't I? Oh, it's 74 as well, isn't it? Okay, so that's probably someone telling me that, yeah, 74. Cool, thank you. Okay, so y is root 74, and we're actually going to leave it in that root, and you'll see why. So this length across the bottom here is root 74, so we can add that to our blue diagram, root 74. Now we can work out what x is, what ag is. So x squared is 74 squared. Oh, sorry, root 74 squared, that's important. And that's why we've left it as a root, so that we can then square it again. Plus 3 squared, which is equal to 74 plus 9, which is 83. I can do that one. So x is root 83, which is approximately equal to 9.11. So hopefully that makes sense. I am going to hop back into the quiz. I know we've barely done any 3D trig, but to be honest, because we've done all of the trigonometry, we don't need to go over it that much. It's if we look at all of the questions that we have on here, let's go on to this one. It's all, so this one, you can see where the triangle is. This is one's a bit trickier, but we're just going to make a triangle from A to O to V and down again. It's all just about spotting the triangles. And you all did really well on those quiz questions at the beginning. So that's why I wanted to focus more on vectors, just because that was the one that was less well answered at the beginning. So do let me know if you don't understand 3D trig, and I'll come back to it at the end if I have time. We've got 10 minutes, so hopefully we will. And I'll explain it when we go through this anyway. So let's redo the Kahoot. It's the same Kahoot. Hop onto kahoot.it or the Kahoot app and enter this game pin. And it's exactly the same Kahoot, but hopefully, so before it was 36%. So hopefully we'll see an improvement. Fingers crossed. Gosh. So yeah, cool. There are 30 of you, so I'll wait till there are about 30, at least 20. Glad to know I still look high. Maths Made Easy, teacher. I still used Maths Made Easy for the 3D trig. Okay, is anybody still waiting? Oh, there are still people joining. Okay, anybody still waiting? To be honest, there are only 5 of you who aren't on. And they might be not here. Okay, cool. I'm going to get started. I think you can join whilst it's going anyway. Okay, so let's see. First one, we want to write 2a plus b as a column vector. So we're given a and b. So in case you can't see it, a is 3, 8, and b is minus 7, 2. And we want to write that as a column vector. So let's see how many people can get this. Yeah, awesome. Well done, guys. So let's have a look at what we do. We do 2 lots of a, so just multiply each bit by 2, so that gives us 6, 16. And then we subtract, we add this, so we subtract 7 from the top, so that gives us minus 1, and add 2 to 16, so that gives us 18. Perfect, well done. Okay, next question. We're going to have a diagram, and we want to know what the vector is from B to C. So from the point B down to C. So ignore that point D. That's just there for a different part of that question that I copied. So give it a go. Remember to think about the negatives. Which way across the lines are we going? Excellent. Yes, that's so many more than last time, because last time a lot of people went for the green answer. Fantastic. So we're going back along this one, so it's a minus 3a, and forward along this one, so it's a 4b, plus 4b. Perfect. Well done, guys. Just checking the chat. Yeah, some of these questions are copied and pasted from Maths Made Easy, some of them from other websites online. So what's the vector from x to y this time? Again, think about the direction that you're going. Oh, someone's asked for the game pin. I can't remember, I'm sorry. 444 something, not that that helps. But if you haven't got in, just have a go at, does it say it anywhere on the screen? No. Oh, there you go. 4442915. I'll there you go. Typed it on there. Cool. Yes, excellent. Well done. So I think the people who put yellow, you've accidentally added them both. When what you've got to spot is that this 2a plus b is going backwards. So it's actually, we do minus 2a minus b. So we end up with 2a plus 2b. Fantastic. Okay. Ooh, Emma overtaken by Lilac. Close at the top. Okay, so now parallel, which I got wrong before. So which one of these is parallel to a plus 2b? So remember, think about what it means to be parallel. Excellent. Yes, majority got the right answer again. So the reason that it is 3a plus 6b is because that's 3 times of this. So it's a multiple of this one. It's 3 lots of this. So hopefully that makes sense to those of you who missed that. Well done. Okay, hopping on to the last 2 questions, which are 3D trig. So, oh yeah, this is the one that I'm actually not 100% sure I did correctly. So let's have a look. I guess we'll see what people get. I've got a slightly different answer to what's on here, and I'm not sure why. It might be that I just copied the answers and the answers were wrong, but I guess we'll see what people get. Yeah, most people got that. I actually got 12.84, but that might just be me. I'm doing some silly arithmetic. But basically, you had to work out A to C. What was the extra question? What's the length of EG? Oh, I was working out EC. Smart. Okay, so so what we actually want to work out here is see that this is the same as A to C. which is 10 and 7. So you do 10 squared plus 7 squared, which is 149, and then root 149, which gives you 12.21. So I was right in the answers, and as were most of you, smarter than me on that one, so well done. Okay, last question. Another 3D trick one. Okay, bit harder. But yeah, give this one a go. Brilliant. Well done, guys. So what this one was here was we've got to spot that we're looking for GC. So we call that X, and that's opposite. The 16 is the hypotenuse, so we want to use sine. So we say sine 35 is X over 16. So X was 16 sine 35, which is 9.81. So well done. Absolutely smashed it that time. Oh, the top 3 all got 6 out of 6. Congrats. So the Black Heart, Emma, and Lilac. So well done, everyone. And I think that was definitely a huge increase there. So let's see what the percentage is now of everything correct. 58%. Yes, way up from 36. So that's amazing. And each question, there are none marked as difficult when fewer than 50% get it right. So there are none marked as difficult. Brilliant. Super, super pleased with that. Well done, everybody. Okay, people are asking for the math joke. Yeah, I've been having a look and looking at the ones that have been sent. We've got some good ones today. So I've actually finished on time 2 minutes early. This is unheard of. Who even am I? So let me just, okay. Thank you all very much for coming. I hope that everything made sense today. Do check out the My Tutor online school timetables. We've got loads more coming up this week. I think 3 periods a day. So check them out. And I will personally see you all tomorrow, I think. So we'll finish off on a maths joke. Oh gosh, there are 2 that I really like. So I might spoil you guys with 2 today because I'm so impressed with the increase of percentage. So the first one is one that I just found, which is the Wright brothers these are both quite sophisticated ones. So, you know, really above my usual level. So the first one is the Wright brothers must be vectors because 2 of them made a plane. So that have a thing, because they created a plane, and because 2 vectors, when you they make it what's called a plane, maybe I'm over explaining it. And the other one is that someone sent me. I think Emma sent it to me. Honestly, don't worry if you don't get these jokes. And this one is what do you get when you cross a mosquito with a mountain climber? Nothing, because you can't cross a vector with a scalar. And that's because a mosquito, I had to Google this, mosquitoes are apparently vectors, which means that they carry diseases, and obviously mountain climbers scale things. And like I said at the beginning, you can't cross them together. I mean, you can multiply them, but there's a different thing called crossing, which you can't do with them. Anyway, sorry about the quality of those jokes. They're honestly clearly too highbrow. But yes, do check out My Tutor online schools, and also My Tutor offers lots of one-on-one tuition, which can be super, super useful. So thank you all very much for coming. And I will see you all tomorrow. Thank you guys. Have a great day. Bye.